So, yesterday we just did one transformation. Today we're going to put all the transformations together and do multiple. Now, yesterday's transformations, if you're just doing left and right combined with up or down, the order doesn't matter so much. You're going to end up in the exact same spot. But once you start throwing in reflection somewhere or a stretch or compression, the order absolutely matters. So that is basically what we're going to be practicing today. This right here that I have highlighted is the general form for all the transformations. You have a basic function. You're either adding or subtracting something here to x. And so right here when we say about the order of transformations, you want to do parentheses first or grouping symbols. We're talking about this piece. Okay, and that's going to be your horizontal shift. So left or right is the first thing you're going to do every time. After that, you'll notice it says multiplication. That's reflections and stretch or compress. That's going to be here for A. That's a stretch or compression. If it's got a negative sign, it's a reflect over the x-axis. You might also have a multiplication right here in front of the x, making it a -1. That is a reflection over the y-axis. And we'll talk more about that here in just a little bit. Mirrored, that's right. Yeah, that's what someone said. Is that what someone said? Yes. Yeah, it's a dilation, which is either a stretch or compress, a specific kind of dilation, but yes, that's a dilation. And then the last thing you're going to do, just like if it was PEMDAS, is add or subtract, and that's going to be this thing on the outside, and that's your vertical transformation. So left to right first, stretch, compress, reflect next, and then up or down last. Okay, so it's kind of like following the order of ops. It's also kind of like working from the inside out. Like if you just find x in your function, then you do the closest thing to that, and then the next closest thing, and then the farthest thing. So either think about it like order of operations, or think about it like working inside out, or just straight memorize it. Left to right, stretch, compress, reflect, up or down. What we're going to do first is practice just recognizing the shape of something that's been transformed. We're not actually going to do the transformation itself. So what you have here is a function, and you have two possible choices for its transformation. And so what I want to encourage you to do here is think about the parent function first, or identify it. What's the parent function here? Identity, and it's just y equals x, right? So it's just x. And its basic parent graph just looks like this. All right? Now these things right here, there's two kind of three transformations that have happened. We have a compression, a reflection, and an up by 2. Now, even if you don't understand what all those is, I'm not the English teacher, what all those are, what do you think is a really key identifying feature here that gives it away? The +2, right? Because what happens, that +2 means what happens to this point? It goes up 2. So which one of those is that, left or right? Left, right? Because you can't even really quite tell the compression here. And maybe you still don't understand reflection, but you can, by just deducing, you can say, okay, that +2, or power of, what is it when you eliminate all the possibilities? Elimination? Anyway, that thing makes it this graph. Right here, we have negative square root of x plus 6. What is the parent function here? Square root, okay. And here's what its parent graph looks like. It just looks like this. And if I were to talk about the transformations, there's two transformations going on here. And if I was following the order of operations, I would take care of, bless you, anything in parentheses first. Well, this doesn't have parentheses. But that square root symbol works like parentheses because it groups things together. So that's where I'm going to start, is under the radical. So this is a +6, but it's also insider's lie. So this is actually going which way? To the left 6. So my first transformation is left 6. Also, if you're thinking about working from the inside out, you start at x, and the closest thing to x is +6, so you do that transformation first. After that, the next transformation is this negative out front. So a negative out front of the function means you're going to reflect over the x-axis. So a negative out front, and if you want to just make this note somewhere, a negative out front means you're going to reflect over x. A negative inside means you're going to reflect over y. Okay, this is a quick tip. And that's because on the first one, you're taking the opposite of y, and on the second one, you're taking the opposite of x. And that's how it reflects. So in these examples, they've both been shifted left 6. But which one has been reflected over the x-axis, the left or right? The left one, right? The left one. So they've both been shifted left 6, but this one reflected over the x-axis, because originally it was here. So it went left 6 and then over. Anybody need that up anymore? Okay. All right, here we go. The absolute value of x minus 2 minus 5. So there's two things going on here, but here's my parent function, and its parent graph looks like this. If we're following the order of operations, do we take care of the minus 2 first or the minus 5 first? The minus 2, and that's an insider's lie. So which way is it going to go first? Okay, so this is a right 2. And then we take care of the minus 5. It's not inside anything, so it's not lying about anything. So we're going to take it at face value, and which means the graph is going to go down 5. So of these two graphs, left or right, which one went right 2 from the apparent function and down 5? The left one. Okay, because this was the original. It went right 2, down 5 to get there. So the first part of your homework has graphs like this, but a whole bunch, and then it has maybe 8 problems, and your job is to match them. All right, so that's why I was sort of guiding you through that process of how to think about it, because once you see all of them all together at the same time, it can be a little overwhelming. All right, so that was just recognizing. Now we're going to do our own transformations. So these are the instructions for the rest of your examples. Graph each function using shifts of a parent function and a few characteristic points. And we want to be sure that we state or indicate these things. We're going to write down the transformations that we're going to use, and we're going to label their special points. Remember, each one has a different kind of special point. It's either an initial point or a vertex or an inflection point. Whatever its special point is, we're going to label it. Right? And don't forget, that's kind of like PEMDAS, or working from the inside out. So here we are starting with the square root of x minus 3 plus 2. The parent function is what? Square root of x, okay? And what are the parent points for square root of x? What are the 3 main ones that we like? 0, 0. What's next? 1 and 1, because 1 is easy to square root. What's the third one that's easiest after 1? 4, 2, right? 4, because that's easy to square root, and it gives me 2. So this is my parent function that we're going to do transformations on, all right? So PEMDAS, if we're working with parentheses first or grouping symbols, am I taking care of minus 3 first or plus 2 first? The minus 3, that's inside, so it lies. So we're doing the opposite, which is to the right 3. So me writing this down, this is me indicating the transformations. So like when you're on your test next week, if it says write down the transformations used, you can do it just like you could write words if you want. I'm just going to do arrows and stuff because it's easier. And then the next transformation is which way? Up 2. Now, in this particular problem, we could mess up the order and still get the right answer, but I'm going to practice this good order so we can have a solid foundation for when the problems get harder. So you take your parent points and you just move them right 3 and up 2. So I'm going to take my 0, 0. I'm going to go right 3 and up 2. Take my 1, 1, go right 3 up 2, and then the last point. And that'll be a solid line because that's my final answer. And labeling the initial point here is at 3, 2. And that's a good warm up for our transformation. Does anybody need that up anymore? Let's talk about this one. What's the parent function? Okay, quadratic. Here's the parent graph. So we know that our final graph is going to be something, it's going to be a parabola somehow. But let's talk about the order of the transformation. So consider your PEMDAS. Parentheses first. What will be my first transformation if I'm taking care of inside the parentheses? Right 2, okay? Because that's insider's lie. So my first thing is going to be right 2. After that, in order of operations, we have multiplication. That's any stretch, compress, or reflection. What is going on here? It's a negative out front. A negative out front means reflect over which axis? X. Because your y is basically changing signs, your y value. So it'll go, like if you had a positive y, it's now going to be a negative y. So that's where the reflection over x comes in. And then addition or subtraction last, that's the plus 5. So my graph is going to go up 5. Take a moment and try that. One thing at a time, and be careful with your order. So I'm going to take this one baby transformation at a time. So my parent function looks like this. Right? Got this going. And then in blue, I'll do to the right 2. So all I'm doing right now is taking those points and moving each one to the right 2 places. So that gives me a point here, here, and here. And I'm just going to form it a little bit just so I can see where I'm looking at. Okay? So I've shifted everything to the right 2. Let's talk about what it means to shift over the x-axis. You're going to think of the x-axis like a mirror, and it's going to reflect this blue stuff on the other side of the mirror. All right? So this point that's on the axis doesn't change anywhere. But this left point that's at 1, 1, it's 1 above the x. I now want to reflect it 1 below the x. This one is 1 above the x. I need it to go 1 below the x. And so now I'm here at the green. Okay, that's what it means to reflect over the x-axis. And then I can do my plus 5. I'll do that in purple. So now I take each of those points and just shift them up 5. 1, 2, 3, 4, 5. Okay, and then this is my final answer. So if you want, as you're practicing these problems, maybe do, so where I did red, blue, and green, maybe you just want to do light pencil in each one, and then your final answer you just shade it in real dark. I know it can get easy when you're doing each transformation separately to like, now you've suddenly got points and lines everywhere and you get lost. Just find a way that works for you and stick to that. And then we want to label what kind of special point is that? Vertex, initial point, or inflection point? Vertex, right? And it's at 2, 5. So who got that right first time? Who didn't get it right, but now they get it? All right, perfect. That's progress as well. All right, this is a beautiful problem. Yes, ma'am.
Do it normally and then just reverse it?
Do you mean like over 2, up 5, and then reflect it down? In this problem, yes, but it's not a good habit to just do it like that because that won't work for every kind of problem. So I, as your math teacher, must insist that you try and follow the steps. And this next problem might illustrate that for you. So this next problem has been upsetting people all day because they shift the vertex, right? And then they just fill in their dots after that, or they just do this stretch. Okay, this problem is not going to work like that. So in this problem especially, we're going to be very careful that we're doing the steps in order. So let's first talk about the order of that you need to do, and then I'll let you try it. And it's only when you combine reflections with compressions and stretches that this sort of that this happens, that you have to be careful. So what is the parent function here? Cubic. All right, so we got a cubic. We know that the original graph looks like this. And so our final graph is going to be something like that, some kind of snaky thing. If you're following PEMDAS and you're working inside the parentheses first, what do you notice? How many transformations are inside the parentheses? 2. So we need to take a moment and figure out which one to do first, all right? Because when I said earlier, you're kind of working from the inside out, like what's closest to the x. Well, those are equally close. X is being multiplied by a negative and it's being added to 2. So in this case, that sort of shortcut fails. But what you can depend on is the steps on the front of your notes. Horizontal shifts, which is what plus 2 is, come before reflections, which is what that negative in front of the x is. So that is just going to you have to remember that order. Horizontal first, reflections next. So in this case, when we're starting inside the parentheses first, we'll take care of plus 2, which is an insider's lie. So our first transformation is left 2. And then a negative in front of the x is a reflection over what? Over y, right? Because this is changing, this is taking the opposite value of x. So if your x was a positive 4, now it's going to be a negative 4, which flips it over the y-axis. So that's going to be an over y reflection. And I want to just give you a heads up about something. It's not over the y-axis that's been transformed. So like when you do this first step and you move your graph to the left, and then you try to reflect over y, it's not this new transformed y. It's only this y-axis every time, this one, not the one that moves with your vertex or initial or inflection point or whatever this problem is. So left 2 over y, okay, so that takes care of our parentheses. Then we look at any multiplication. What multiplication do I have? Times 3. Is that a stretch or a compress? It's a stretch, okay. And let's talk about what that means. Stretch by 3 means this. Your x value on your transformed point stays the same. The y value is times the 3. Okay. So you'll have some transformed point that you're working on. The x will stay the same. The y gets the times 3 treatment. And that's what stretch 3 means. And then after that, after the multiplication, we have add or subtraction. Last, we have that negative 1. That means down 1. So take a few moments, very carefully, one step at a time. The biggest thing I want you to remember here is when you do reflect over y, you're reflecting over the actual y-axis, not your shifted y-axis. All right, so here we go. The parent points for x cubed are here, here, and here. So that's my parent function. What is my first transformation? Just left 2. That one's easy, right? So everything goes to the left 2. Here we are. So I did that in red. Let's talk about what over y looks like, okay? Over y means this point here, the 0, 0, it's 2 to the left of y. I now need it 2 to the right of y. Okay, so that point shifts over there. Right? This, that was the 1, 1 shifted. It's 1 to the left of y. I need it 1 to the right of y. And then this bottom left point is 3 to the left of y. I need it 3 to the right of y. So that is the reflection over y. Who got that? That one's tricky. Most people all day have been right here. They've been imagining the shifted y axis here, and they just take these points and rotate it right there. But it rotates all the way over to here, right? Or it reflects rather. So then let's talk about stretch by 3. So I said for stretch by 3, your x values will stay the same. Your y values are times 3. So right here, the 0, this is 2, 0. 2 stays the same. 0 gets times 3. Well, what does that give me? Still 0, right? And if you need to see that, like maybe your brain just doesn't hold that information in one spot for you, you can always write it down, right? Write the point down for yourself. 2, 0 becomes 2, 0 because you're timesing 3. This point, this 1, 1, x is staying the same, 1 is times 3. Okay? You don't have to hold that information in your head if that's not working for you. Make some scratch notes. So now this point goes up here. And then this point, that's 3, negative 1. The x stays the same. Y times 3 gives me negative 3. So it stretches down here to negative 3. So now I'm here. And the very last thing, and I've run out of color, so it's time for teal. Everything goes down 1. Right? So my purple points are now going down 1. And I connect them. Yeah, this is the last transformation. Right there. And the inflection point is 2, negative 1. Oh my goodness. All right. Did y'all survive that? Yeah. Okay. Let me give you your homework.